Hello and welcome to this session focused on configuring site-to-site VPNs on Cisco iOS devices using static virtual tunnel interfaces of SVTIs. As always, we're going to cover some quick main points with regards to SVTIs, and then we're going to jump straight into the labs and start looking at the configuration and what exactly is required in order to get our site-to-site VPN established. So static virtual tunnel interfaces, or SVTIs, are similar to traditional point-to-point VPNs, but they are intended to be more flexible. And there's a few reasons why, and I've stated those there on the PowerPoint. So there's no need to apply crypto maps to the physical interface. So where we configure traditional point-to-point VPNs on Cisco iOS devices, we need to first configure our crypto map, and then we apply our crypto map to the relevant interface where that tunnel is to be formed and that traffic is to be sent. If you've not seen in my other previous videos on YouTube, please go back and take a look if you want to learn more about the configuration that I'm talking about. I do have some videos focused on configuring traditional point-to-point VPNs on Cisco iOS devices. So this is one of the benefits that we get with using the virtual tunnel interfaces, because we not only don't have to create those crypto maps, we can actually get rid of those totally, and when we create the tunnel interface, we don't have to apply any crypto map to that. And we'll take a look at how that is done and how that works, how the device knows how to send certain traffic or interesting traffic across a tunnel. And we basically do that by configuring static routes. So we'll take a look at that in the lab. So as I've already alluded to, and it's probably given away in the name anyway, we're actually making use of virtual interfaces as opposed to the physical interfaces. And again, when we get into the configuration, you'll see exactly what I mean by that and what sort of configuration takes place or is applied to the virtual tunnel interfaces that we configure. Now, virtual tunnel interfaces support multicast, which is great, and also unicast traffic, but they're the only two that VTIs are limited to. So do bear that in mind if you are wanting, greater flexibility. With regards to tunnel encapsulation, we can still make use of IPsec and encrypt that using either encapsulating security payload or ESP or authentication header as well. And lastly, I've put there that this is a good deployment if you're wanting that flexibility for smaller sites, let's say site-to-site connectivity, maybe a couple of sites. But if you are looking at configuring and having a more flexible approach to VPN configuration in general, then for larger sites, then you may need to start looking at other VPN methods such as DMVPN or FlexVPN or even GetVPN. And in upcoming videos, we will take a look at some of those as well. I do actually also have some articles on my website, so www.networkwizkid.com, where you'll find some VPN related articles and configuration as well. So feel free to check those out as well. So with regards to configuring static VTIs, we have a few things that we need to do. The first one is optional. So we configure our ISA-KMP policy, and I'm not going to spend time assuming that the people watching this video have already got that baseline knowledge with regards to why some of these options are optional. I'm not going to spend the time going through that, but what we will do is in the lab, we'll take a look at why the why in a little bit more detail rather than explaining it. I'll show you in the actual lab. So we start off with either configuring the ISO-KMP policies, which, as I say again, are optional. So you don't have to configure them unless you've got specific policies that you want to create. We then go on to configuring the transform set, and again, that's optional, as well as the IPsec profile that can be configured. And then we configure that tunnel interface that makes up that virtual tunnel interface. And then lastly, we'll conclude with configuring static routes. And that's really, as I said a little bit earlier on, this is really what's going to identify that traffic that needs to be sent over that tunnel. And that's the difference really between the sort of traditional way with the crypto maps and doing it using the tunnels where we don't need the crypto maps. So this is a lab we're going to focus on today to do our configurations, and we're just going to focus on the right hand side of this lab here. So we're going to focus on the partner network and also the branch network there as well. And we're going to configure between router 5 and router 6. We're going to configure that VTI or that site-to-site VPN using static virtual tunnel interfaces. And then what we're going to do is we'll finish off by using our virtual PCs at each site to ensure that we can get across that tunnel to establish that communication. And then lastly, we'll finish off with sort of just verifying that those tunnels are created and verifying the configuration as well. If we transition over to our lab now, we've got our router 5, we've got our router 6, we have our virtual PCs there, so virtual PC 3 and virtual PC 4. And we'll start off just by taking a look at the configuration. And you'll see that everything is just basically standard. So we've got the interface IP addresses configured. We have our IP routes. Basically, we've got a default route to the ISP, let's say, the CSR, which is in the middle of the topology there. And then the rest is just unconfigured or default. And we'll have the same when we take a look at router 6. So we just got the IP address and the static route configured there. So we're pretty much ready to go. With the VPCs, they just have an IP address configured and can communicate with the gateway. So if we try to, from VPC 3, which is on the partner site on the top right, if we try to ping 192.168.20.50, which is the VPC 4 IP address, this should not work. So you can see there that that's timing out because you don't have that connectivity to that network. So that should change once we create that VPN and we've finalized our configuration on both router 5 and router 6. So if you recall back to the presentation where I looked at the configuration steps that were required and pointed out that a few of those were optional, the reason being is because we have default configuration that exists on the devices that will take precedence and will be used if no additional configuration is carried out. So with regards to the ISO-KMP policy, if I was to do show crypto ISO-KMP default policy, you can see here, if I just enter it out there, you can see that we have a number of default policies here with different priority values. So you can see we've got one here which has a priority of 65,507, all the way down. So the lowest priority is the one that's going to take precedence. So in this example, if I wasn't to configure an ISO-KMP policy, then we would make use of the one of these. So preferably it'd be probably this one here with the lowest value, so 65,507. So we've got a few different ones here. So you can see here default, 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 default. So if we was to create one, and do, run a show command as well, we'd be able to see ours. But you can see here by default we have a few that are configured here. So as you can see, this has got a lifetime of a day. We've got defilement group 5 being used. Our authentication method is in fact, we wouldn't be using this one, because if we were using pre-shared keys, we'd actually make use of this 65,508 priority here. So same configuration, it's using AES-125 encryption, secure hash, so SHA, and pre-shared key. So we probably make use of this one here. So that's why that is set to optional as well. And if we also did a show crypto IPsec, you can also see here we've got a default IPsec profile here as well. So we can see that it's got some default configuration basically set there as well. So these are the reasons why it's optional. And you can see that we've got a default transform set in there as well within the IPsec profile. So we can actually leverage these just to make our configuration a little bit easier and a little bit more simple. So what we'll do in this actual demonstration is we will leverage those, and we'll see how we get on and just see how simple it is to configure as well. So we do need to create a pre-shared key to begin with. So let's just go into global configuration and let's create our pre-shared key size KMP key. Let's just give it Cisco, and our address is going to be the IP address of, so we're on route, let me just go back to the topology there. So we're on router 5 at the minute, which is the partner router on the top right hand side there. So we're going to configure our P address as the outside interface of router 6, which is going to be 209.209.209.10, and that's going to be our pre-shared key for that. Now, as I said, we're not going to create our phase 1 policy. We're not going to create our transform set or our IPsec profile. What we will do is we'll just go straight into the tunnel. So if we do interface, and we'll say tunnel 0. So now you can see that's come up, but it showed us that the status is up, but protocol's down because we need to configure it. And it's give us this new interface that you can see here. So now we're in the interface configuration mode. What we can do now is we can actually assign the relevant configuration, because we need to, it's a virtual interface, so we need to specify still a physical interface to which the virtual interface will send that encrypted traffic to inform that tunnel from. So what we do is we start with IP. So on the what we'll do is we'll say tunnel source is going to be our Ethernet 00, which is the external interface of this device. Our tunnel destination is going to be the IP address of the router 6, so our branch site external interface IP address, so 209.209.209.10. We don't need to specify the subnet mask there. Our tunnel mode, you can see there that the state's changed to up now that we've assigned the tunnel destination. Our tunnel mode is going to be set to, so if we just question mark that there, you can see that we've got a few options. We want to leverage IPsec, so we're going to say IPsec, and then we're going to say IPv4 because we're using IPv version 4 IP addressing. Okay, and that's gone down now, but don't worry about that. That will change once we build that tunnel. Now, our tunnel, we need to specify, so if we say tunnel protection IPsec, and we need to specify our IPsec profile, and we've not configured one if you recall correctly. So if we just specify default, and if you remember, so you can see that that's turned our ISO-KMP on now. But if you just remember when we looked at our IPsec profile, we can see that that's default. So our IPsec profile was default. So we've just basically specified the one that already exists, so we don't have to configure one as well. So we're leveraging that and making our configuration a little bit easier. And once we've done that, the last thing that we need to do is if we just come out of that interface now, we need to create an IP route or a static route for our traffic, our interesting traffic. So we want to be able to, from our partner site, from our internal 10.0.10.0/24 network, we want to be able to reach the branch site on the LAN, so 192.168.20.0/24. So that's going to be our interesting traffic. So we need to create a route. So anything that's going, so if we just say an IP route, anything that's going to 192.168.20.0, we're going to 255/24. We're going to send that via our tunnel. So if we just say tunnel 0, and that's basically how we create our SVTI, and we're using that static route to do that. So for those that are familiar with the more traditional approach with the crypto maps, we've not created any crypto maps. We've not applied any crypto maps to the tunnel interface whatsoever. So it's made our configuration a lot more flexible and easier to configure overall. So if I just do show IP route, you can see now we have let's do static. So yeah, it's only showing that static one yet, and that's because we've not got the tunnel built yet. So once that's up, we'll come back and look at the routing table, and we'll see what we can see in the routing table. But if we do show IP interface brief, you can see as well that the protocol's down, so it's not going to give us any sort of information there as well. Let's just go back into that do show run interface tunnel 0. Okay, so we might be missing a command here, so with the IP address. So let's just go back into tunnel 0 and yeah, so IP unnumbered, and we're going to specify our physical interface, our outside interface of ETH00. So we're not giving this an IP address. We're basically saying we're using the external interface, the external physical interface of that device, which is the Ethernet 00. So now if I just do show run in tunnel 0, Yeah, so now you can see IP unnumbered as well. So we've not got no IP address for that tunnel interface. Okay. Okay, just checking the tunnel there. That's down. Yeah, so method's fine. All right, cool. So we should be good now with that configuration. So what we'll do is we'll configure the not the VPCs yet, because we still will be able to ping. What we'll do now is we'll do the same configuration on router 6. Quickly go through that now that we know what is required. So we'll do crypto, ISACAM key, Cisco address, and our address this time is going to be the external interface of router 5, 209.209.6. And again, we're not going to create no ISACAM policies. We're not going to create no IPsec transform or IPsec profile. We're going to leverage the default. So we'll go into interface tunnel 0, IP unnumbered, and we're going to use Ethernet 00 as our external interface. And then we're going to say our tunnel source is also ETH00. Our tunnel destination is going to be the external interface of router 5, so 209.209.209.6. Our tunnel mode, if you remember, was going to be IPsec, IPv4, and our tunnel protection for our IPsec profile was going to be the default one that we were leveraging. So you can see it's actually told us that we're using our default policies here. Default policies. Okay. And then lastly, if we come out of this and we create anything that's going to 10.0.10.0, we want to send that via tunnel 0 because that's our interest in traffic. All right, so now you can see that tunnel's actually showing up. So it looks like you can see here as well, it's built the, it looks like it's built the tunnel now, and that tunnel's established. You can see as well that the state of this interface on router 5, which is a partner site, has changed to up. Let's just verify that. Yep, you can see that's up there on the bottom there. Now if you do show crypto IPsec SS, you can see we've got security association there. And if we check we'll come back to that. I just want to check the ISACAM PSA. You can actually see that we've got a security association with the bottom one is which we're focusing on there, which is showing as active as well. So that tunnel is now built. Now if we just go back to the IPsec SA, you can see what it's showing here for crypto map is actually showing our tunnel, showing tunnel 0, and it's showing our local address, which is the outside interface of this device. We can see our local and remote identities are showing as all zeros. We're using the tunnels, but we can see our current peer is the router 6 external IP address there as well. We have no encrypts or decrypts yet because we've not sent any traffic from any of the virtual PCs, so we'll do that next. Again, you get some more information here in regards to the local endpoint or the local external IP address, as well as the remote endpoint IP address. And then you got following information such as SPIs, and you've got that you could correlate as well. And then you've got the inbound ESP/SAS, as well as the you should have the outbound one further down here as well. So you can see the transforms that are being used. And remembering we didn't set any of those, we were using the default policy as well. So that's just, you just saw really how easy it was to actually configure that and get that up and running as well. So let's just send some traffic now from VPC 3 to our branch site, which is ping. So if we do say ping 192, in fact, I could just up arrow there, and we'll try to ping VPC 4. So where it failed before, as you can see, this should now be successful now that tunnel's established. And there you go. You can see that that's successful. And we can also verify that that's successful by actually looking again at our IPsec SA. So you can see that we've got 5 packets that have been encapsulated, encrypted, and then you've got decrypted as well. So you can see that you've got 5 that have been encrypted and 5 that have been decrypted. So if we see here 1, 2, 3, 4, 5, that's those 5 that we've just sent. Also on the other side, so on the branch side as well, we do IPsec SA. Let's just do detail actually, but let's go through all this. And if we see again, we have the same incaps and decaps, so we can see as well, the packets that have successfully arrived, they've been encrypted, they've been decrypted as well, which is great. When you do the detailed output, you get a little bit more information with regards to the actual IPsec Security Association as well. So there you go. So you can see that that's successful, and then we'll just finish off from the branch site. We'll go to ping VPC 3, and you can see that that's successful as well, which is great. And again, if we just have a look there, you should see the incaps and decaps increase, which they have. So we've got another 5 that's being added on to the last 5 as well. So let's have a look at the routes again. So the routing table. So now you can see, because tunnel 0 is up, where we didn't see that static route before that we configured, we can now see that that static route is in the routing table, because that interface is up, that tunnel's established, and everything is running as it should be as well. So now we can actually see our static route going via our tunnel. And that is pretty much what I wanted to go through on this particular demonstration today. So that's actually covering how we can configure Cisco IOS devices using static virtual tunnel interfaces, or SVTIs, with site-to-site IPsec VPNs. I hope you found that useful. Please do like if you have found this useful. Please do subscribe if you haven't already subscribed, and show your support. And if you have any questions, feel free to pop them in the comments section. I do try to communicate and stay up to date with everybody, so don't be shy, reach out. But that's it for today. Thank you for watching.